Hello and welcome to the much requested part 29,498 of the How to Make a Game Like Minecraft in Unity series. And in this video we are going to do block behavior, so like spreading grass, falling water, that kind of thing. So before we get started, because it's me, we're going to fix a error from my previous video. So those of you who've been following along word for word may have noticed that there's a little problem with the water. So if I just plonk a block down, all the water gets opaque, or at least the water in that chunk, and if I plonk another block down it gets more opaque and more until it's basically not transparent anymore. The reason for this is quite simple. If we just go into our chunk class, and you can see we have these lists here for triangles. We've got triangles for regular blocks, we've got transparent triangles for like glass blocks, and then we've got water triangles. That's relevant because if we go down to clear mesh data, you can see we clear our triangles and we clear our transparent triangles, but we don't clear our water triangles. So let's do that. And that fixes that problem. So we're going to do block behavior, and in order to do block behavior, we need an increment. We need like a schedule to update our blocks. So you can't just have it update every frame because, well, for one thing, that would be extremely intensive on the computer because you'd be trying to update all the blocks, 60 times a second on a normal machine. So that's no good. So we're going to implement what Minecraft calls a tick. And to do that, we are going to use a coroutine. So let's go into our world script, and just anywhere I'm going to put it. Oh, no, sorry. Before we do that, we need a tick length. So let's go to Voxel data. We'll put it in here with the rest of our public static information. Public static float tick length, and I'm just going to set mine to equal 1. So this is seconds. So this, if I set this to 1, that means that we're going to have a tick every second. I'm not sure what length Minecraft does it at. You're entirely, free to change it to whatever length you want. I'm just going to put it as a second because it's nice and round and easy. So now we want to, well, we'll save that first. Then we want to go back to world, and I'll just put it here just above update. We need an IE numerator, which we're just going to call tick. And then we're going to do a forever loop. So while true, because while the game's running, we want the ticks to be running. And then in our loop for now, all we're going to do is debug.log tick, which should just show us that it's working. And then we need to do a yield return new, wait for seconds, and then this is where we get that voxel data.tick length. So that's our tick loop for now, and then the only other thing we need to do is start it. So if we go up to our start function, and then at the very end, because we don't want it trying to run tick updates before the game's finished setting itself up, we're just going to say start coroutine tick. So let's just test that and make sure it works. Get the console open, and there you can see we have ticks. So that's our tick update loop kind of thing. So the next thing we're going to do is we're going to go into our chunk, and we're going to create a tick update in here somewhere. So this is going to be a public void. And in here, we're just going to say debug.log chunk object.name. So it'll give us the name of this exact chunk. And then we're going to say tick update called. So just once again, all it's doing is just telling us that it worked. So the key thing here is that we don't need to update every chunk that we've got in the save file or in the game or whatever. We only need to update the ones that are loaded and active. So in here, let's just get rid of this. We don't need that anymore. We're going to say for each chunk code, just call it C, in active chunks c.x c.z tick update. So now it's only going to update chunks that are currently in the active chunks list. So there you go. Now we're getting an update saying that individual chunks are being updated, not just the, not just saying there has been a tick. It's saying a tick update has been called for chunk 5051, chunk 5150, etc. So the next step is to have our chunks do something in that tick. Now to handle block behavior, we're going to create a new class, and in that class we're going to have two functions that take in a voxel state. One of them will be a bool for determining whether a voxel has to be updated during the tick, and the other one will be the actual code that executes when an active block does need updating. So let's make that script. I'm just going to put it in here, and I'm going to call it block behavior. And then the first thing we're going to change is this is going to be a static class. It doesn't need to be a mono behavior. So obviously we don't need, well, in fact we can't have those. So let's start off with our public static bool, which I'm going to call active. Takes in a voxel state, which we'll just call voxel. And what this is going to do is it is going to tell us if the voxel that we pass in here is active. And what we mean by active is, well, firstly, is the block a block that does anything? So a stone block or a dirt block doesn't do anything. So there's no need to ever run a block behavior on a block that has no behavior. But we're not actually taking care of that in here. We'll show you that shortly. But what this does is it tells us if a block that has behavior can do anything. So in this video, we're using grass as an example. So an example of a grass block that can't do anything would be a grass block that is surrounded by blocks it can't spread to. I'm keeping the rules simple in this video. So we're only going to have it spread to dirt, which I think is how Minecraft does it anyway. But it's only going to spread to dirt. So if a grass block has no dirt blocks around it, then it can't do anything. This is just a bool where we pass in a voxel and it says, can this voxel do whatever it is this voxel does? So the first thing we need to do is determine which voxel it is. So voxel.id, and then we have our cases. Now these cases are going to correspond to the ID of the block. So block 0 I believe is air block, and then block 1 I think is stone, and so on. Obviously there wouldn't be any stone or dirt block cases in here because those blocks don't do anything. And then at the end of here, if we haven't returned true already because of one of these, then we just return false. So that's this one, and then I'm just going to copy this because most of what we're putting here to start with is the same, only this is going to be a void, and I'm going to call it behave. And we don't need to return false, obviously, because it's not a bool. So the switch statements in both functions correspond to the block ID. I'm just going to use grass for this video, but you would have a case for every block ID that has a behavior to it. So you'd need one for water, you'd need one for tree saplings, you'd need one for lava. Any block that can do anything, you'd need to, you know, update, like a redstone block, for example. You'd need to have a switch case in here and in here. As I say, we're doing grass, so let's get started on the grass. And I'm going to stick a little comment here for my own benefit, just so you can easily see which block is doing what. And then we can put our code in the active bool for checking if a block needs monitoring to see if it can do whatever it does. Now that we can put our code in for the active bool to check if the block needs monitoring to see if it can spread, in the interest of keeping things simple, I'm only going to have the grass spread to the blocks to the side of it if the block is dirt. We're not going to spread up or down. It's only going to spread to dirt blocks. So we need to know the ID of dirt. In my game, it's 5. You might have it different in your game, but you want to, if you're copying me as I'm doing it now, you need to know the ID of the dirt block. Now we made this easy for ourselves by storing each voxel's neighbor in the voxel state class, so we don't need to go looking for a voxel's neighbor. We can just look at the voxel's neighbor class and pull out the neighbor we want. And because we know the order of the 6 neighbors, because it's the same as if I just pull up, is it voxel data? Yeah. Because it's always the same order as this. It's always back, front, top, bottom, left, right. Then we know which neighbor we want at any given time. So we know that we're only going to be checking neighbors 0, which I believe is the front or the back. The back. 1, which is the front. And then 4, which is left, and 5, which is right. We're not bothered about 2 and 3 because that's top and bottom. And like I say, I'm not spreading grass in that direction. So let's get started with the code. If I go up here, this is a bit of a eyeful, is this? So we want voxel.neighbors 0, so this is the back neighbor, the neighbor behind it, and we want to make sure it doesn't equal null. And the reason we need to do null checks is if your view distance and your update distance, your loaded distance are the same, you could end up with a voxel trying to check a neighbor that is not on the map because it hasn't been loaded yet. You could also have one that is at the edge of the world, or you could have, like in blocks where it can spread upwards or downwards, you could have a voxel that is at the top of the map or the top of the chunk or the bottom of the chunk, in which case you don't want to be trying to check a null voxel because you'll get a null reference exception. So first off, make sure it's not null, and then we want to say voxel.neighbors 0.id is equal to 5. So that's saying, does it have a neighbor in this direction? And if it has a neighbor in this direction, is that neighbor an ID of 5? Is it a dirt block? We can hard code this because this code is specific to this block. So it doesn't matter that this isn't variable. I mean, like obviously if you were doing it a proper game, you would migrate this out to something like Lua or something so that you could easily modify this stuff from the outside, but that's a whole other tutorial by itself. Then we want to say or because this is just a bool telling us if this block can spread. So it doesn't matter if it can only spread to one block. If any blocks around it can spread to, then we want to be returning true. So then we obviously need to do the forward block, the block in front of it, the block to the left, and the block to the right. Remove that last or statement. And then the thing that we're going to do for now is just say debug.log grass block with potential to spread has been found. And then we're just going to return true. So because we're returning true, we never get further down here and we never get to this return false part. If we do get all the way down here, we return false, and that basically tells whichever code is asking that this block that has been checked is not active. So that's all we need to worry about there. If it returns true, however, it's telling us that there is a dirt block next to our grass block, and we need to execute code on this block to see if it will spread to those dirt blocks. If it returns false, however, there's nowhere for the grass to spread to, so we don't need to update that block until something changes. Let's run a quick test. We're going to put some code at the end of our check chunk edit voxel, chunk.edit voxel? Yeah, chunk.edit voxel function, and we're doing it there because this function is only called when the player edits a block and not when the world gen modifies a block, for example. We also need to check all of the neighbors, because if you put a dirt block down, the dirt block itself isn't going to do anything because it's a dirt block, but if there's a grass block next to it, that grass block needs to be double checked because it can now spread. Let's just save this and go back to our chunk, and we want to find edit voxel, and then I'm just going to put this down here. So first off, just to make things a little bit easier, let's just grab our voxel so we're not having to type in all of what I'm about to type in every time. Chunk data.map, and then it's x check, y check, z check. And then we want to say for int I equals 0, I is less than 6, and then obviously I plus plus. And then the thing we're going to do here is we're just going to say block behavior dot active, and we're passing in voxel dot neighbors and then I. So this is actually checking all of the neighbors, because even though I'm doing grass to spread only to the sides, this isn't for the block that we've just placed. This is for the blocks around the one that we've just placed. So even though the grass is only interested in the blocks to the side of it, there may be a block above it that changes depending on what you've put underneath it, or a block beneath it that changes depending on what you put on top of it. Save that, and we'll just do a quick test run. Now if I go over here and I place a dirt block down, you can see that we've got grass block with potential to spread has been found down here. And the reason it's shown up 3 times is because we've got 2 times here. Both these grass blocks can legitimately spread, but also because the code at the minute doesn't factor in whether a dirt block has anything on top of it. Obviously this grass can't spread to the block under here, can't spread to that one, because there's a block on top of it. Now our code isn't checking for that. Our code just thinks that this block can spread to the dirt block at the side of it, for example. So when we update a block that factors that in, it gives us a, it registers that it's got grass with potential to spread. I might not bother adding that in with this code because there's a lot to get through, and it's, it's fairly straightforward. You just want to be checking above the neighbors, but I have to leave something for you to do by yourself. So next we need a way of keeping track of blocks that are active so that we can run code on them every tick. Just like we're only running tick code on active chunks. And because this is real-time information, as in information that we wouldn't be saving to file when we save the game, I'm only going to put this stuff in the chunk class rather than the chunk data class. So let's go back to our chunk class. And first we need a list of active voxels. So I'm just going to put it there, that'll do. List voxel state active voxels equals new list voxel state. And then we also want some functions for adding and removing to this. So let's just go down here out of the way a little bit. So these are public, and the reason for that is so obviously we can add and remove stuff from the list from outside of the chunk class, but also we can put validation in here. So public void add active voxel. I apologize if you can hear banging in the background, but there's a bit of a gale force wind blowing at the minute. So this is going to take in a voxel state, which we're just going to call voxel. And then all we're going to do in here is if does not active voxels dot contains, and then we pass in voxel. So basically we're just saying, is this voxel already in the list? We don't want to add a voxel that is already there. And if it is not, if this statement returns true, if it is not in the list, then we say active voxels dot add voxel. And that's that. For removing a voxel from this list, we need to do a little bit more. So public void remove active voxel. Again, we're taking in a voxel state. Now we want to do a for int I equals 0. I is less than active voxels dot count I plus plus. And then inside here we say if active voxels I is equal to voxel, we remove it from where it is. So active voxels dot remove at I, and then we return. We don't need to do anything else with that list because we should never have any duplicates. Now, because these functions are public and because we have a complete path that we can track back from our voxels to our chunk, we can go through, I believe it is from the voxel we get to chunk data, from chunk data we can get to the chunk, and then from the chunk obviously we can call these functions. Basically all the blocks need to be checked at least once to see if they're active. That's going to bog down the game a lot at the start, as well as any time a new chunk's generated, because the game will have to cycle through all those new blocks and then run the code to check if it is red or whatever. Because active blocks need to be checked to see if the conditions around them warrant any code executing, but there's many blocks that don't ever need looking at, such as stone blocks, dirt blocks, we don't have to run the code on everything. So one way we can get around that is if we go into our world and we scroll right down at the bottom here, or near the bottom, we've got our block types class. We can add a bool here, and we'll just call this public bool is active. And then if we go back to Unity, and what we can use this bool for is basically to eliminate the need to check a block. Because if we know that if, I'm just going to do grass here, so set grass is active to true, and then all the rest of them will be set to false for now. Obviously you would be setting water to an active block, and you'd be setting furnaces to an active block. Because we have this bool to check, we eliminate the need to check the vast majority of blocks in a chunk. If you think about an average chunk, most of the blocks are stone and dirt and wood and things like that. So we don't need to check any of those. So this eliminates that need. So next up, we're going to add some code to the constructor of our chunk class. So let's go back to chunk and all the way up to the constructor, which is here. And then I believe we want to be putting it just after this line here. So it's the last thing we do before we add it to the add chunks to update, because we don't want any risk of it trying to update this chunk before we've run this bit of code. So we need to loop through all the voxels in the chunk, and I'm just going to steal this here to save me typing. Paste that there and get rid of that because we're not doing that. So then in here, we're going to say voxel state voxel, just to again make things easier. Chunk data dot map, and then we're going to say x, y, z, and then we just want to say if voxel dot properties dot is active, add active voxel, and pass in that voxel. So now that's going to go through all the blocks in the chunk when the chunk is first created, and it's going to check if any of those blocks are blocks that can be active. So it's not going to add any stone blocks, it's not going to add any dirt blocks, it's only going to add blocks that can do stuff. In the case of my game, that means it's only going to add grass blocks, because that's all we're doing in this. So let's head into our chunk.tick update, which is down there. And we're just going to change this debug log to give us a bit more information. So chunk object dot name plus space currently has plus active voxels.count plus active blocks. So now it's going to tell us exactly how many active voxels there are in each chunk. Now, just to be clear, this first run, all of the voxels, or nearly all of the chunks, there are some exceptions because of certain like biome changes and stuff like that. But because my game is spawning in a grassland biome, and because my world generation code is quite simple, we're going to get 256 active blocks for every chunk. Like I say, there's some exceptions for where like the biome changes and there's like dirt or sand on the surface, but for the grasslands biome, grass is on the surface and it's just set to put grass everywhere. So 16 by 16 is the size of the chunk, 16 times 16 is 256. We're going to get 256 active blocks for every chunk, or every chunk that's a grasslands chunk. As you can see in the debug, we are getting 256 active blocks. So the first bit of behavior we'll give it is to check if there's a block above it. If there is, the block behavior will be to remove itself from the active voxels list and change itself to a dirt block. So let's go to our block behavior script and down to our behave function. And then in here, we're just going to say if voxel.neighbors, and it is 2, which is the voxel above it. And first off, we want to say does not equal null, because we could be the topmost block in the chunk. And if that's the case, there will not be a neighbor above it because we don't store neighbors higher than the chunk height. If it's not null, and voxel.neighbors 2, and there's various ways you could do this. I'm just going to say if it does not equal 0. So if the block above our grass block is anything but air, then we're going to execute this code. And this code is going to be voxel chunk data chunk dot remove active voxel voxel. And then also voxel dot chunk data dot modify voxel, and we're just going to pass in the voxel's own position because we store that, and then the block that we're changing it to. So for me, it's 5 because that's what dirt blocks are in mine. And then finally, the position, really, it doesn't matter because dirt blocks don't have a direction or anything. Not position, sorry, rotation. Dirt blocks don't have rotation. They're the same in all directions, so we don't need to give it a rotation. Obviously, if you were changing it for a block that is directionally sensitive, you would need to put in code to make sure it faces the right way. And then once we're done, we can return. Although I don't suppose that really matters, but I'm going to return anyway. Oh, no, sorry, that does matter because we're going to be adding more code after this if statement before the break. And if we've done this, we don't want to do what we're going to put here. Now we need to head back to our chunk.tick update function. That's easy to say. And execute this code. Now we're going to do this by looping through the active voxel list and running the behavior code, but we have to loop backwards because some of the behavior code is going to modify the list. Like this code here removes things from the list. So if we go from the top to the bottom, we're going to be looping through a list that's changing as we're doing it. Whereas if we go from the bottom to the top, like we've left behind the bits that we've changed. So start at the bottom, work your way up, because 0 is always going to be at 0 regardless of how long the list is. I have no idea if that made sense. So let's go to our chunk tick update, and then in here we're going to say for int I equals active voxels dot count -1, because we're actually starting on the active voxels. That's inclusive, so it needs to be -1. And then I is greater than -1, and then finally I minus minus, because we're de-incrementing it, not incrementing. And then in here we're just going to say block behavior dot behave active voxels, and then we're going to pass in I. So let's give that a run. And when this loads up, there should be a few things that we can notice as signs that we're making progress. So thing number 1, if we scroll down here, you can see that some chunks are changing their block active block numbers. Like this one has down to 0. In truth, they should all be down to 0, but that thing I mentioned earlier on about not checking to see which neighbors have blocks above them, that's going to skew the numbers a bit. But really, they should all be 0 because all of the surface is grass, and you can't spread grass to grass. But these blocks here, across the side here, they're counting the blocks that are under these blocks as potentially spreadable blocks. So the next thing we notice is that it is all dirt under the water now. It wasn't before, but now it is. And if the final thing is if we go over to this tree, you can see it's dirt underneath. That's because all of these grass blocks have been checked and they've seen that there is a block above them, so they've changed themselves to dirt and removed themselves from the active block list. Now, we want to get rid of that bit of code that we added in chunk.editVoxel because that only checks when the player modifies the voxels. So if we just go do that now. And the reason we want to do this is because obviously the player isn't going to be the only one that modifies the voxel. But when the player does edit a voxel, it calls the same script that the game does, that the world gen does. So when the world gen modifies a voxel, it calls the chunk data script, which is, where's it gone? Which is in our data, chunk data, down here somewhere, modify voxel. So this function is called anytime a voxel is modified. So if we put that code in here, then it does it automatically when a player edits it, but it also does it when the game edits a voxel. Now we need to do a few checks, obviously, because we don't want to get null reference exceptions. So if we go into where we're going to put this, just before we add it to the add to modified chunks list, we'll put it there. So we're going to say if voxel.properties.isActive and block behavior.active voxel. So what that's doing is saying, is this block a block that has the potential to be active? And then if that's true, we're checking if it actually can be active. So this is like saying, is this block active? It's a grass block. Yes, it can be active. Is this block surrounded by any dirt blocks? Yes. Then we carry on. If no, we don't do any of this. And then chunk data dot chunk dot add active voxel. So that is adding, if those things are true, we're adding this voxel to its chunks, its parent chunks active voxel list. Then we want to basically do what we did in the chunk.modify or edit voxel, whatever it was, but with a few modifications. So int I equals 0, I is less than 6, I plus plus. And then inside of here, the first thing we do is say if voxel.neighbors I does not equal null. For the same reasons that we said before, we don't want to be trying to do anything to a neighbor that doesn't exist. And then another bit of a mouthful here. If voxel.neighbors properties active and block behavior.active voxel.neighbors then if that's true, so if the neighbor is both active, same as this, if the neighbor is both active and it is able to, do something, voxel.neighbors i.chunkdata.chunk.add active voxel neighbors I. Basically, we are just doing the exact same thing that we've done here, but we're doing it for all of this one's neighbors. So now anytime a voxel is modified, its neighbors are checked to see if the modified voxel affects its active status. So an example of that would be we put a dirt block down next to a grass block. The dirt block itself will not have anything done, like this will return false because it's not active. But it will check the neighbors, and if one of the neighbors is grass, the grass block will see the dirt block that we've just put down, and that will add itself to the now active list because it can potentially spread to that dirt block. So let's build on our block behavior. Firstly, we're not removing all of the blocks that are inactive at the minute. We're only removing ones that are underneath something like a tree or water. The first thing we want to do is to check all of the active blocks status in the tick update and, remove all of the ones that can't spread. So grass blocks that don't have anything on top of them but are surrounded by other grass blocks, they can't spread. So they don't need to be in the active list. So let's go back to chunk, find our tick update, wherever I put it. There we go. And we want to modify this. So inside of this loop, we're going to say if not block behavior dot active, and we just pass in the active voxels that we are currently looking at. Remove active voxel. However, else, we want to do what we were doing before. So now our code will remove any block that is no longer active, such as a grass block that has been surrounded by other grass blocks. So an example of how that might come about is if the grass has spread, a block that was previously active because it had a dirt block next to it may no longer be active because grass has already spread to that dirt block. That's one example. And if we run that, we should see that a lot of chunks are reporting 0 blocks. The whole thing about not checking neighbors' blocks above them, that's going to mean that not all of them are completely 0, but there should be a lot of 0 blocks. So if we look down here, no need to remove that. You can see we've got active blocks 0, 0, 0, 0, 0. We need to remove this bit of debug. We don't need that. But you can see it's removing blocks. Let's just delete that. We don't need to know every time it finds one because it's going to be finding a lot. So now that everything's in place, we can code our grass to spread. I'm not sure what the specific rules of Minecraft grass spreading are, but I'm going to have mine only spread once per tick. So you'd have probability checks, but basically I'm not going to do any sort of timing on mine. Mine's just going to be every tick. If a grass block can spread, it's going to spread once. It's not going to spread to more than 1 block per tick, but also it's going to spread every tick if it can. So let's go back to our block behavior. Oh, we're already in our block behavior. Let's go down here and add that code that I mentioned earlier. So the first thing we want to do is create a list, new list, voxel state, and then we want to populate that list. And the way we're going to do that is say if voxel.neighbors, and this is going to be 0, so we're checking the one behind it first, does not equal null, and let's just copy this again, because I don't like typing despite doing it for a job, and ID is equal to 5. We're going to say neighbors.add voxel.neighbors 0. Spell neighbors right. So what this is saying is if this block is one not null, this neighbor being the back neighbor, the one behind the block we're looking at, if it's not null and it equals 5, we're adding it to this temporary list that we've created. And we're just going to copy that and then do it for the other neighbors. So the one in front, the one to the left, and the one to the right. Same over here and same over here. Just as a check here is say if neighbors.count is equal to 0. That means that it's done a check and none of the voxels to its around it are voxels that can spread. Then we just return. And then we're going to say int index equals random.range not neighbors.count. This is just to give it a bit of randomness. It's just going to pick one of the available neighbors at random and then say neighbors index dot chunk data dot modify voxel, and then once again we're passing in neighbors index dot position, and the voxel we want it to be is 3, which is the grass. And then once again it doesn't matter about the direction. Well, I mean, it does matter a little bit because you could flip a grass block sideways, but we don't want to do that. We want the rotation to be standard. And that is all of the grass behavior I'm going to be doing in this video. So our world is full of grass blocks at the moment, so it's not going to do anything. So to properly test this, let's just go into data, go into biomes, and find grasslands. And I'm spawning in a grassland on my game at the minute with the current seed. So if we go to where it says surface block, and I just change that to 5, now the surface blocks are all going to be dirt. So let's try this. If I just run up here and knock one of these blocks out and then drop a grass block in there, it spreads. And that is that. That's the tutorial. So yeah, for those of you who keep asking about running water, you should now have everything you need to be able to do that. You've got block behavior, so you've got the means to tell water to look around it, check its state, if there's nothing at the side of it, spill out, basically. You've got the means to make blocks with different shapes from when we did half slabs. You just do the same thing, but you want water shapes, obviously. And you've got the means to do animated water textures, which we did in possibly the last video, I can't remember. But yeah, that's pretty much it. So all that's left to do now is to thank my amazing Patreons. My amazing patient Patreons. I appreciate that it's been a bit longer between videos than I usually do. But the special thanks go to, of course, the Sugar Daddy / Mama Tier Patreons, who are Dave Maldine, Reg Reed, Gabriel White, Aaron Clark, Mr. Drunken Dragon, and Julian. And thanks to everyone who does all the liking and the subscribing and everything like that. Hopefully it won't be as long till the next video, although I should point out that I am currently going through the process of moving house, so everything's a bit all over the place at the minute. But again, thank you for watching. We shall be back soon with another video. Bye bye.